Aspects that we'll be talking about today then is a slight review of what we were doing yesterday, but one of the aspects is we need to remember how to calculate atomic masses then. So, someone give me, what is that? Okay, well, that is very annoying. Please stop. Okay, so what we need you to do is give me an example of a metal, any metal. Okay? Two or three? Okay, so if we had iron 2 phosphate, okay, what we need to do then is, what's the symbol for iron? Okay, and then the phosphate ion. Okay, now, one of the aspects that we had said is always go by the negative ion here, which phosphate has a charge of negative what? Okay, so iron can have a charge of what or what? So then how do you know which one to put down? The Roman numeral tells you what to put down then. Okay, so this is a +2. So the least common multiple would be what? And it's 6. So we said the answer that you get by dividing them tells you what to put below. So you divide them all or both into 6. 6 divided by 2 is, and then 6 divided by 3. And I know you may be looking at that and saying, well, it's -3, but it's not a value, it's a charge. Okay? It has nothing to do with the value. Right? So, now we know that that adds up to 0. The charges, well, the charges don't add up to 0, but the ratio now does. Maybe that's a better way of explaining that. So, as a review from, let's say, chapter 3, I believe, how would we go about this process? For instance, how many atoms are found in, we'll just say 1001. We'll make it a palindrome. That is a palindrome. Yes. Now, see, now you know what a palindrome is. It can be numbers. It can also be words. Yep. Yep. Okay. So now, we'll even make it a little more difficult. We'll say kilograms. Oh. Kind of like a sucker punch into the gut, huh? Okay. So, this is just a little bit of a review. So, what we want to do is, first thing, we got to get that guy into grams. You can do this one of two ways. You can start with this, or you can just do the math in your head. You can just take it times 1,000, or you can write the dimensional analysis on here. And what we mean by that is, for your kilogram, you've got 1,000 grams. That's what we're saying by multiply by 1,000. Okay? So, 1,000. So then, what we can write down then is 1001, 123 grams now. So one of the things we can do, rather than writing out Fe3PO4 parenthesis 2, since we know this is iron phosphate, we can just do this. Just so you know that that's iron phosphate, because you're going to have to add all of them together. Have we lost anybody? Because this is a review. This, as someone had mentioned, is probably about the end of the first week into the second week of school, which was 7 weeks ago already. Okay, you're a quarter of the way done, basically, with the school year. Okay, so one step closer to senior year. Yes? Okay. All right. Okay. How do we get rid of that gram in the next step? You got to get it into moles. How do you do that? Okay. So, does grams go on top or the bottom? Then what goes on top then? Okay. So, do we just throw a number in here? We just grab it out of the air, or what do we do? Okay. So, iron is what? So 55.85. 111.7. Okay, so there's our irons, but we need one more, don't we? Not two, we need three. I was just seeing if you people were paying attention. So 167. So there's our irons. Okay. And phosphorus is somewhere around 30. For two of them. But then how many do you have? So that's what I'm saying. So what is 94.7 times 2? 189.9. Okay. 189 point whatever. Whatever. Okay. Okay. So then you got your 9, 14, 17, 1, 7, 8, 15. Okay. So then that 357. Okay. 0.49 goes there. So our grams of iron phosphate have canceled. We're in moles of iron phosphate. And how do we get rid of that? On the bottom? Okay. 6.022 times 10, 23rd, atoms, IP, or could be molecules, either one. And then your mole goes on the bottom. They're gone, so then you multiply them out. This calculator isn't advanced enough, so a slight review, because one of the aspects that goes with this content is not only just writing out the compound, but also adding together the atomic masses. Because this is the very beginning, or setting the stage for the dreaded stoichiometry that a lot of students have said is it's tough. It is. That's what you mainly do and start with in the spring semester in January when you come back from Christmas break. But this is where some of that information starts, because part of this chapter is what we consider molecular and empirical formula calculations, and also we call it molar mass and percent compositions. So, for instance, what that means is if we have 1001, well, let's see here, 3, if we have 1,000,000 grams of iron phosphate, okay, what percent of that is phosphorus. Okay, that's steady. That's starting the very beginnings of what stoichiometry is. The only reason that it's not classified as stoichiometry is because you don't have a balanced chemical reaction. That's the difference. But you solve them in a similar manner. Okay? So, is anybody lost so far? Okay? We're naming compounds. Okay? I think we're doing quite well. I think what we will do is move up Friday to Thursday, and then because it would appear like we said, if I put about 8 examples up there, how many of you would feel that you don't need to do that? If you don't, that's fine. Or do you still want the added practice?
Because all we're doing is just like finding, and if we have to learn, we do. But the only difference is that we're using these compounds. Right? You just have
Yes.
to make sure how to, which we worked on through GCOCT17, right?
That is correct. Yes.
Like
That's why we said we're going to find, when you were a freshman, we said we're going to find out in 2 years how many of you are actually paying attention. And maybe you all were. That's why the rest of your class isn't in here, huh? Okay. Okay. Yep, that is correct. Well, so a lot of these we've been writing the formula. So what happens if we have the formula and then we got to go backwards and write the name? So we'll go ahead and do one like that. Go ahead and do but sometimes those Roman numerals do match up. Okay. Not in this case, unless yeah. We'll keep it simple. Okay. Okay. So SN is 10. Okay. And we've got chloride. And we said we always go by your negative ion, which is this, -1 times 2 gives you -2. So then this has to be a plus what to add up to 0? Okay. All right. Okay, let's of this already? Oh. Oh yeah. Fair enough. What are you doing back there? Okay. So let's see here. Yep. Yes. There's only 4 of them.
Of the acid, but we have to name like the NH4.
You know them too. It's not that difficult.
You say that.
But then, yeah, I get that because we've been doing this for a few years, but just think of the way I look at it. You know, we're driving afternoon route for a bus. So yesterday wasn't brutal. It was, I just happened to go the wrong way, or I didn't go the wrong way, it just extended the route a little bit because, as you know, when you get out in the country, uh, this you have streets that are avenues that are, for instance, 467 and 467A. It's one that doesn't quite go all the way through. Maybe it goes up to someone's farm place, and then it doesn't go all the way through to the next mile. Depends who's all riding. Mr. J, because he's combining. Yep. Yep, yep. Okay. So let's. Okay. Antimony. Look at 33. Yep, yep, yep. Okay. Excuse me. Oh, it's 2 or 5. I'm sorry. I thought it was 2 or 3. So that needs to be rewritten then. Well, this table over here is a little more advanced than yours. I had the right idea. I just didn't quite do it correct. Okay. So what I mean by that is this shouldn't have been a 2. Should have been a 3. And that can still be 2. All right. So we got our first positive ion, CO3 is what? What? 35 seconds. Excuse me. Okay. So now keep in mind, one carbonate ion has a charge of -2. But how many do you have? So the whole thing is negative what? I think a common mistake is if you're not paying attention, you look at this and you're thinking, oh, this has a -3 charge because there's a 3 in there. And that's very easy to do. You just might not be paying attention or something to that effect, and you look at this and you go, oh, that's got a -3, so then maybe this has a +3, which, or +4, depending upon what that is, because it has more than one charge. Antimony can have plus what or what? Okay, so if we put a +5 in here, we'd have a total charge of plus what? 10. That does not add up to 0. But the other alternative, +3, does. Okay, and I don't know if you remember from physical science, is when you're looking at these, when you have these numbers down here, notice that the number that you have matches the charge. So sometimes you can crisscross that and think about it and just think, oh, well, since this has a charge of -2, well, we got 2 there. This has a charge of +3, and we got a 3 there. So it's antimony 3. Okay, but I would just continually just do the math in your head, then you know it's always going to work out. Okay? So, do you feel you need more practice adding them together? And please do a better job of writing Roman numerals than what I do. So, that does say 3. But, yeah. All right. Left outside, we're on the bus. Left middle. I guess there's only left side, middle, right side. Okay. All right. So, tomorrow we will have something like this for you to work on, and you'll be adding together atomic masses, naming these, writing formulas, and that will be due a week from yesterday, which will be the 23rd. All right. That's it for today. We'll pick up with this tomorrow.